Hi. Somebody wrote to me last week and he was trying to fix his laptop because it was heating and used to turn off. And he decided to open it, try to find out what is going on, and to put new gray paste in the microprocessor and video chip. Something went wrong. For some reason, the laptop that was turning on and turning off after heating now is dead. Something happens there. It was last week, and 2 weeks and a half ago, one colleague, he called me to visit his business because he was fixing a laptop. He is a professional. The first guy who wrote to me is a beginner and professional with business and everything. He was fixing the laptop. He made a test. It was working. In the procedure to put the plastics back, he made another test, and now the laptop is dead. Happens the same. Okay, this week I got another laptop to fix from somebody else in the same conditions. I wanted to talk about because it's a common problem. It happened to them. It could happen to us. As I said, one of them is a beginner, but the other one is already a professional. And what I want to say is, if we do not pay attention, it doesn't matter who we are, it will happen to us. Period. To understand what is going on and the problem, we will start by the definition of voltage. Voltage is the difference of potential, electrical potential, between two conductors. Sounds easy, but it involves more things in the concept. We have a laptop, as giving an example, it could be tablet, it could be a medical equipment, it could be a desktop computer, industrial electronics board, whatever. We have to source some electricity, and we use the adapters, the power supply. We are expecting the adapter and the power supply to be regulated voltage. We're trusting it. We get the voltage for our laptop example because they can go for laptops from 12, 16, 15, 18, 18.5, 19, 19.5, 20, 21, 22, even 24 volts. Power supplies, adapters for it, chargers that we call. In our case, for 18.5, I connected to the main board, it should work. And if it is 18.5, everything is perfect in the theory. Inside of the laptop, we have switching power supplies with the step ups or step downs. In our case, for step downs. And we will drop that voltage, those 18.5, to the lowest voltage we can to make the microprocessor to work efficient without heating. Microprocessors, they are bigger today and they require more power, so what they did was to drop the voltage in order to dissipate less power. If we pay attention to the following picture, we will see an example of Intel microprocessor. The voltage to source that microprocessor is 1.5 volts. We will get another input with 1.8 or something alike, but still being very low voltage compared with the old microprocessors that they used to have +5, -5, +10, +12, -12 volts. If we remove the ground and we see the value peak to peak, we are talking 10 volts, we are talking 24 volts. But those voltages, they are very high compared with nowadays processors. Now, it's easy to make the mistake they made it, and we will talk about in this video. We'll talk about it because we can make it. it could happen to us. And as I said, the definition of voltage is the difference of electrical potential between two conductors. And let's pay attention, because I said the concept is very open. And from my input, power input, to the processor, there is a big voltage drop that must be regulated. And also, something that nobody pays attention, is the voltage ground to ground. Yes? What is the voltage ground to ground? We assume it is 0, right? Okay, maybe it's not 0. And maybe it could be one of the reasons why we burn the equipment. Let's see it out in the lab. Many things can go wrong. One of them, to drop a screw when the laptop is connected. Sometimes the nut from the screw get broken in the plastics and it comes out, and we get under the board any kind of metal trash that can make a short circuit. Once that we ensure we will working clean, what I always do is I put my big piece of rubber and insulate everything on the way. Now, supposedly, nothing can go wrong. I'm ready. I have my connector, my adapter is plotted, and with the volt meter I will check here. And my voltage is there. Now, as I told you, we have steps down voltage from 19 volts to 1.5, 1.8 something. If I touch the board with my fingers, I will probably bypass high voltage from one point to the other. That's one of the easiest way to make a short circuit if we are not leaving metal trash or making a short circuit with something. Extra knowledge. The test leads, they are big enough to fit between two pins in the ICs, between the chips, and make enough short circuit on it. So now we know how to make a bypass and give the wrong voltage on the wrong place. What about the ground? I told you. What is the voltage between the ground? I have my 19 volts here. We just saw that. So I'm assuming this is a grounded point, and I want to connect my monitor. So let's see the voltage from what should be negative to negative, the ground to ground in DC. It says 2.8 volts. Okay, that's more than the microprocessor volts. And let's see that value in AC. Surprise! 100 volts. How come? It should be the negative. Yes, it is. There is not any discussion about it. Same as the bumper in a car. The negative side, the ground in the chassis, is made on the way that when I connect this connector from the monitor, like a bumper in the car, it will compensate and will absorb the difference of potential, that shock. The other problem is if I am exposing the board and I make the mistake, like everybody, trying to hold the board with my hands and connect the plug in the other side, making a bypass myself. Do you understand now the problem? So there is not 2.8 volts difference, almost twice of what the processor needs. I'm making a bypass of 100 volts myself, because if the laptop is with the plastics, as I said, like a bumper in the car, it will absorb that difference of potential shock. If it is not, and I touch everything with my fingers, then I'm giving a big trouble to the board. More mistakes on the way. We say we're touching the negative, and I have here the soldering iron. Let's pay attention to the voltmeter. 62 volts AC. 34 volts DC. So even if I disconnect the board from the electricity, let's say I will disconnect this guy from here, and I'm going to do the solder there, but I will connect this other guy and I will forget it. Let's see how is it now. The monitor is connected, not the power supply. There is 100 millivolts DC difference there, but in AC is 180 volts. Easy ways to kill the equipment. And as I told you, the best way to kill the equipment is because we don't have the plastics when we try to hold it in our hands to connect something. One of the videos nobody likes, one of the videos nobody sees from me, I just checked it out and it's 75 viewers only. I make a video about how to change the memory in a Dell computer. Guys, if you pay attention, the first step in that video was to remove the battery. I removed the battery, and I didn't need to remove the battery theoretically to touch the memory in that computer. Why? Because I only need to release the screw under the keyboard and release the keyboard, and the memory got exposed. Why did I remove the battery? Because if I attempt to put or to place or to remove the memory with voltage, probably I will make a short circuit and I will damage something. I recommend you to watch the video, and when I make videos, I'm not teaching exactly what the title says. When I make a video as a teacher, I try to teach something else. Go to watch those videos. Maybe you don't need to replace a Dell Vostro memory or to upgrade it, but the concept of what has to be before that is important is what I wanted to teach you in that kind of videos. Something else? Yes, there is a worse way from the soldering iron, from the power supply, from the holding it, from the difference of potentials. What we assume is 0 volts, the mass should be the ground. There is something worse, and the easier and the worst way to kill the mainboard. Let's see it. For the next experiment, I will use a piece of paper, scissors. I will play like in the kindergarten. And now I need a piece of plastic. I will scratch it in my clothing. And now I will put it on the papers. What is going on there? The answer is very easy. Electrostatic electricity, the difference of potential between a place full of electrons and missing electrons in these atoms. My clothing, my body, is enough to kill a laptop. This is the way to solve it, to protect the laptop from the electrostatic discharge. How to kill a laptop? Not like that board, like this one. That was the one my colleague had the accident with. And you will say, okay, but this plastic is a different kind of plastic. You cannot pick up those papers so easy. Are you sure, guys? That's enough to make this laptop to die as it died in the middle of the assembling and testing. As we saw it, it's easy to make a mistake. Beginners is a big frustration. The first hit against the electronics will frustrate more than one, I bet. But also it happens to us as professionals, as old guys, the guys who always do the same thing, the same procedure all the time. We jump on one step, we don't take care of something, and we get a negative result, a consequence that somebody has to pay. And sometimes mistakes like that, we have to pay it with our life, not with a dead laptop. Once in my life, I was working. I was already engineer with a lot of years of experience. I was working with 480 volts. And I said I will grab this area with the electrical tape and I will hold the thing in my hand. And I did it. And the voltage, the difference of potential between that and I don't know what else, passed the electrical insulation of the electrical tape. I'm not talking I got a kick, I got electrocuted. That thing was stuck in my hand, and I was checking my arm to release that thing from my hand, and it was almost impossible. As I could, I stepped in the cable and I could move the arm in the way that I separated. I got terrible burns in my hand. A little mistake in the procedure. We don't see the voltage. We don't pay attention. We can kill a laptop. Another one can kill us. It happens to me. Already engineer. All. I survived it. I didn't die. We can get heart arrhythmias as consequences from it. And when I made my video about what is Cat 1, Cat 2, Cat 3, the category in the electrical equipment, believe me, I knew what I was talking about. Thanks for watching the video. Always pay attention. Remember, do not jump in the procedures. Be very careful. Do it right. See you next time.